know what we are going to learn today? Any idea? No idea. Rahul says, okay. Anybody else? Like, did you see the brochure or the poster? Come on, say something. Okay, let's make it interactive. Okay. So, any idea? Like, maybe if you know, even tell the name of the workshop. If that you know. স্যারটা কে শুনি কি স্যার এখানে সবাই দিদি দাদা ঠিক আছে এখানে কোনো স্যার নাম নেই something related to data science acha okay yes that is true this workshop is about data science and today we are going to dwell more into applications of data science okay we are going to learn about how we apply data science and machine learning. Okay, so it is going. I'm going to try to make it as easy as possible for you because I understand that you are all new to this uh, topics and also you were introduced to Python just yesterday. So I'll try to make it as easy as possible. So okay, spam everybody spam in chat box. Why if you are excited? Okay, if you're excited for the session, spam by everyone. Nobody's excited. Excited? Okay, only one person. Okay. Okay. So okay. Thank you everybody. Okay. I think we are good to begin, right? Okay, so let's begin in 2 minutes, okay? So is the slide show visible? Or are you only able to see the PowerPoint? Is the slide show visible? Okay, I cannot see the chat right now, so please unmute yourself and speak up.
It's visible.
Okay. So you can see the next slides and things. Okay, fine. Let's start. So good evening to everyone. Okay, before starting, are we recording the session? Thank you. So let's start the session. Good evening to everyone. So we are here from Hackerspace community, and today we are going to see a data science workshop for day 2. The presentation is brought to you by Muskan Das from CSE Data Science second year and myself, Nivedita Chakraborty, from today's speaker of the session. Okay. So today we are going to learn about machine learning and how machine learning is going to be helpful in data science. So first we start by knowing different type of data and what are the types of data, and finally by answering the question, why do we even need data, right? So after we know about data, we will dwell into machine learning and know how the data is so important for machine learning models. Okay? Within machine learning, we will be learning about majorly two types of machine learning, that is supervised learning and unsupervised learning. And, and then we are going to get to the real world examples and understand how we use this machine learning in everyday day-to-day life applications. And the most exciting part of the whole journey is understanding and applying these concepts of machine learning using Python. Okay. So after all these crossing all these islands, we are going to reach our goal of understanding basic machine learning algorithms with which will be helpful for your further data science journey. Okay, so since you all have been introduced to Python recently, I won't be going into much detail, but we will only see the applications by using Python. Okay, is this clear, everyone? Okay, come on, respond. Is yes or no? Is this okay? Can we go to the next slide?
Yes, yes.
Yes, yes, we can.
Okay.
Yes.
Okay. So first things first. What is data? Can anybody tell me what is data? We have heard about data a lot.
A set of information.
Set of information. Very good. Okay. Anybody else who wants to give a try? Only one person is excited actually. All of you spammed just like that. Nobody is interested.
Data is a collection of information.
Data is a collection of information. Okay, fair enough, fair enough. So data refers, as you all said, a collection of information or a set of information. But is that enough? A set of information is enough? Because when we take information, we get raw data. What do we mean by raw data? There might be data, incomplete data, or the data might be in various formats which needs to be corrected. There may be wrong data. So the data needs to be processed, organized, and stored in a proper way so that the machines can understand and use these data for further analysis. Okay. So the first type of data that we are going to go through is structured data and unstructured data. So as you can see in the image that the structured data are very well organized and clean data, and they have a well defined structure to them. So what does well defined structure means? Well defined structure means that they can either be stored in rows and columns in form of tables or in form of JSON data or other formats. So has anybody
Excuse
heard
me.
about JSON data? Okay,
দিদি
huh.
বলছিলাম জাস্ট স্লাইডের ফার্স্ট পেজটাই দেখা যাচ্ছে।
Okay. That is what I was asking previously. Okay, I'll share again.
ওটা বোধহয় তুমি ওই সিঙ্গেল শেয়ার করেছো তাই জন্য বোধহয়।
Hmm. Now is it visible?
Yes, yes.
Okay, thank you for telling. What's your name?
সোমশীর্ষ।
Okay, thank you. Okay, so as I was saying that we can see in this image that the data is completely well organized. Okay, it is neat and clean. The data is neat and clean, and these data is this kind of data or well organized data is called structured data because they have a defined structure in them. And what kind of structure are we talking about? We are talking about tables which have rows and columns, or maybe JSON data. So has anybody heard about JSON data?
JSON is like JavaScript object notations, right?
Yes, it is the full form of JSON. But what is it? What is the structure?
অবজেক্ট ফর্মে যখন ডেটাকে স্টোর করা হয় লাইক কি ভ্যালু পেয়ার ওটাকে তো জেসন বলে আই গেস,
Correct,
মানে
correct.
বঙ্গতে
That is,
যেটুকু পড়েছিলাম।
yes, yes, that is correct. Okay, so okay. Okay. So for those who don't know how JSON tracer looks like, it is represented by curly brackets. It might not look like curly bracket, but they are okay. So key value pairs means I have a key. This is a key. The name string is a key and it stores a name. Let's say Amit. Okay. It stores a key. It can also have a different key, let's say score, and which stores an array of scores. Okay. 70 and so on. Right. So this kind of data, key value pairs, is called a JSON data. Okay. Is this clear? Is this visible to everybody? This writings?
Yes.
Okay, fine. Okay, fine. So the next kind of data that we have is unstructured data. So what does unstructured mean? By the name of unstructured, what do we understand by the English word?
Something which is not organized, maybe.
Yes, which is not organized, does not have a well-defined structure, which means these kind of data cannot be uh, structured into a table or a JSON data. So, for the example is text reviews, social media blogs. So, tell me, why is text reviews unstructured data? Why do we call text reviews unstructured?
Because the texts are not alphabetically arranged.
Not alphabetically arranged. Okay, if I have alphabetically arranged data, can it be structured? Is it A to writing A, C, B, A, B, C, D to Z? Is it structured?
দিদি আমার মনে হয় স্ট্রাকচার্ড ডেটা মানে ওই স্টার রেটিং এর উপর যে ডেটা আমরা অনেক সময় রিভিউজ গুলো দিই সেটা ওখানে র্যান্ডমলি 5 স্টার তারপরে 3 স্টার বা তারপরে হুট করে 1 স্টার এরকম ভাবে আসে।
Okay, that is very precise. The stars that we give 1 to 5, that is a kind of structured data, because we can have a table. Okay, we can have a table that stores, okay, user ID and then stores the rating, right? So user A gives 5 rating, user B gives 3 rating. So that is a structured data. But the review that we write, good, not good, and stuff, is this structured? This is not structured. So why is it not structured? Because these can be inconsistent. What I mean by inconsistent, there is no particular format to follow. By mistake, I might give a double space in between here, or I may make a spelling mistake. Okay, so there are too many errors that can occur, and it is inconsistent data. Also, social media blogs have text, they may have images, videos, voice, all kind of data. Okay, so that is a mixture of data and which cannot be stored in table format, and therefore is called unstructured, right? So the next part of data is labeled and unlabeled data. So labeled data, as we can see in the image, we have cats and dogs, but at the same time we have a tag that defines that this image belongs to a cat. We can understand that this is a cat, but machine cannot understand. So we are providing the machine a tag so that it understands what this image signifies. Okay, so if I change this to dog and change this to cat, the machine will think that this is a cat and this is a dog. Okay, so it is up to us to provide the correct labels for the data. Similarly, unlabeled data is something that does not have a tag. We only are providing the images to the machine learning model, which means that the machine at the beginning of the at the beginning does not understand the difference between these two images or these two images. Okay, so these are labeled data and unlabeled data. So next we go to what do we do with this data. We have known what are the type of data and what different examples of data, but why do we even collect these data? So various surveys, observation and experiments give us data, and every organization collects these data. Why? Because to make informed decisions. For example, if there is a company and the company wants to wants what this is not working. Okay, so the company wants to know the state its sales. Okay, so it collects the sales data, and then from the sales data it can understand whether the company is undergoing profit or is it undergoing loss. So these kind of information that we get from data, that is why we need the data. Okay, so after the data, how do we understand whether I have collected the data? Okay, let's say I have collected the data of sales for a company. Now, how do I understand that whether the data is having a profit or a loss? So that comes with different kind of algorithms that we use. Okay, so what do I mean by algorithms? The algorithms are statistical and probability uh, used algorithms, okay, which work on large amount of data. So keep in mind the word large. The large amount of data is used for these algorithms. This is, yeah. So to make different kind of predictions and identify the trend in data. So what does trend means? So if there is a sales data which goes upwards, there is a positive trend or a upwards trend. Okay, upwards trend. If it goes on the other side, there is a downward or a negative trend. Okay, so this is what we mean by trend. And with this data, I can make different predictions for the futures. Okay, uh, so what are the different types of statistical algorithms we know? What are the different type of statistical algorithms we know?
Statistical algorithm. The
Okay.
statistical algorithm, but they're like machine learning related algorithms.
No, simple statistics that you learn in maths. It's also written in the slide.
আচ্ছা আচ্ছা ওইগুলোই okay okay
Yeah, mean, mode, variance. These are simple algorithms that we use, right? What is mean?
The average.
simple average
Average.
of all the data.
Average of two number.
Yes. Right, average. The total number of the data values added divided by the total number of data. And what is mode?
Mode is the data which
Number of
occurs
numbers
maximum
repeated.
in frequency.
Oh, okay. The data values which has the maximum frequency. Good. What is variance? What is
variance মানে
variance?
the distribution from a central data ওরকম কিছু একটা ছিল I guess.
Yes, that is correct. Be confident. You are telling the right answer. Be confident. Okay.
পড়াশোনা করিনি অনেকদিন ভুলে গেছি।
Okay.
Standard
আমি বুঝতে পারছি ফিলিংটা। হ্যাঁ কেটে যা Okay, who is speaking? The voice getting voice is not clear. Your voice is not clear.
Acha, is median not a statistical algorithm?
It is. Median is a statistical algorithm. That is why we have written
Okay.
etc. Okay. So variance is the distribution from the central data. What do we mean by central data? It means the mean. What is the difference? What is the distance between the central data from the mean to other data points? Okay, that is what is variance. And standard deviation is the root over of variance. Okay, so here we see an example for job satisfaction. These are 3 different jobs we have: red, blue, green, yellow, and the employees have rated the satisfaction from 0 to 100, and this is the kind of trend we see. Okay, this is the trend, a bell-shaped graph we see here, right? Okay, so next, so we already have these algorithms. We have these statistical algorithms. We know programming. Why do we need machine learning? We can just program these algorithms now. We can simply program these algorithms. Why do we need machine learning?
To automate things.
Okay, so normal programming does not automate things. Uh, I write a program for I in let's say range 1 to 10, print hello. So this does not automate. This is not automatic.
হ্যাঁ, কিন্তু ওই যে সাজেশন টাইপের দেয় যখন সার্চ ইঞ্জিনে, ওইগুলো তো মেশিন লার্নিং দিয়ে, যে আমি আমার মেশিনে কিরকম করে আমি ব্যবহার করি সেইটা স্ট্যাটিস্টিক্স ওয়াইজ আমাকে সাজেশন দেয়।
Okay. Okay. So any more simple example maybe?
Prediction.
Prediction. Prediction. Okay. Prediction. We can also do prediction using normal algorithms. There are statistical algorithms for predictions. So why do we need machine learning? Any ladies?
Train
All ladies
train
are
the
sleeping.
machine.
Huh? Sorry? Please repeat.
It is used when there are variety of data.
Right. Now she is the smart one. She's reading the slide. Okay. Complexity and variability in data. Okay. So why traditional programming and these traditional algorithms fail? It is because the modern data is very complex. It has variety of data. There is too much variability. So these because of these complexities, our algorithm cannot find the intricate details of the data. Okay, and that is why we need machine learning to reduce the manual error, effort, and save time. Right. So is it clear till now, everyone? Any questions? No questions? Okay. So after knowing what data is, we will see what machine learning is. As we see in this big picture, there are a lot of types of machine learning. So in fact, machine learning is a very broad field. Okay, there are these 3 types are not the only types. There are new various different types of machine learnings coming up every day. Research is still going on. Okay, so as we discussed that machine learning develops algorithms which are statistical or uses probability to enable the computers to learn and make predictions. So those who said make predictions and statistical algorithm, they were correct. Okay, you were not wrong, but we need to start from simple to complex. Okay, so we need to learn the data, to learn about the data, learn what about data, the features of data. What does features of data mean? If I have an image of an apple, so what is the feature of this data? What is the feature of an apple image? Can anybody see? Say.
Shape or color এই দুটো হতে পারে।
Right. Shape and color is the feature of the data, but the background also comes under the data, right? The background. Okay. So if there is a red background and there is a red apple, the machine learning might get confused. Okay. So these data can be learned by the machine learning algorithms and make predictions and decisions without explicit programming. So I'm telling that the machine learning learns data, does not need explicit programming, but still I'm telling that we will be doing Python programming on machine learning. So what are we actually programming? Anybody has any idea?
দিদি আরেকবার বলো কি বললে?
Okay, what I'm telling is that we are telling in the definition that we are learning from data and we do not need any explicit programming, but we are still going to program machine learning using Python. Why do we need Python if we do not need any programming?
পাইথনে তো মডেলস গুলো অলরেডি এক্সিস্ট করে, ওগুলোর উপরে ট্রেন করালেই আই গেস উই ক্যান গেট দ্য আউটপুট।
Not exactly. Not exactly. Anybody else who wants to try?
Access of libraries.
So, see, programming has libraries and there are functions which have already defined, predefined models, but we're still programming, right? We're still programming. So, I'm telling we do not need programming, explicit programming. So, what does this explicit mean?
আচ্ছা,
What
এক্সপ্লিসিট মানে লাইক আমরা ম্যাথমেটিক্যাল ক্যালকুলেশনস এর জন্য অ্যালগরিদমস গুলো নিজের হাতে লিখছি না, ওগুলো অলরেডি আছে।
precisely. So, what we are going to code is this is a box, okay? It's a big Tera box, but it's a box. Okay, so this, let's say this is the outline for machine learning. Okay, this is what we are going to code. This outline of how the machine learning is going to take the input and how the machine learning is going to give the output, right? But what the machine learning is going to do is define the algorithms. It's going to define the algorithms over inside this box. Okay, so this box, we do not know what kind of algorithm machine learning uses. We have no idea because it's very complex to understand. So therefore we call this box as black box. So machine learning is a black box model because we do not know what algorithm machine learning is using. We are only providing the input, output, and defining the model for machine learning, the outline for machine learning. Right? Is this part understandable? Is it clear? Any questions? If there is no questions, then I'll have to ask by calling names. Okay. Let's see who all are there.
Can you just repeat that black box portion? Couldn't able to
Okay.
understand.
Okay. So why we are calling this model of machine learning black box? Because the machine learning is creating its own algorithm. Okay. So what the algorithm looks like, or what is the equation for algorithm? Okay, for simple models we can understand what is the equation of algorithm, but for tough models, complex models, we do not know what the algorithm looks like. We cannot define it as x plus y plus equal to z. Okay, so that is why we do not know what machine learning is doing inside. We only know that the input and output match. So therefore we call it black box. Black box means what? We cannot see inside what is there in a black box. Okay.
Yeah, exactly.
So this is one of the limitations of machine learning. Okay, that is why we cannot always 100% trust machine learning, because we do not know what machine learning is actually doing inside. Okay. So let's go to the types of machine learning. So there are various types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Among unsupervised learning, there are various algorithms that we use: regression, classification, ranking, decision tree, and various other. Under unsupervised learning, we learn about clustering, representational learning, etc. Reinforcement learning is mainly includes robotics, robot navigation, and stuff. So today's session, we will be focusing more on regression, classification, and clustering. Okay, and complete the basic understanding of machine learning algorithms. Okay, so before we go into the details of what these algorithms are, let's just go through what kind of data do we actually, what kind of different examples or application we use every day. So we have spam filtering. Okay, quickly tell me examples of spam filtering. Where have you seen spam filtering?
আমার হ্যাকার
Emails.
স্পেসের গুলো স্প্যামে চলে গেছিল।
Uh-huh. What?
আমার হ্যাকার স্পেসের মেলগুলো স্প্যামে চলে গেছিল, ভুল স্প্যাম ফিল্টারিং হয়ে গেছে।
Okay, okay. So that is what I said, right? Machine learning can never give 100% result. Okay. So someone said emails, right? Another application that we commonly use for spam filtering, very common, other than email.
Truecaller.
Truecaller.
Truecaller, exactly. So what is the data that we use for spam filtering? What is the data?
Maybe repeated.
Repeated. Okay, the number of times.
Repeated, reported. Repeated,
Exactly.
reported.
Very good, very good. Reporting. We have a notion of reporting whether these calls and mails are spam. So these reporting, the number of reporting, okay, the digit, let's say 100 times, they signify how much spam they have caused, how much problems they have caused for users. Okay, so this is a kind, what kind of data is this? Is it structured or unstructured?
Unstructured.
Unstructured. Okay.
Not sure actually.
Okay, give me the reason why unstructured. Then only you will get sure.
মানে আমি জাস্ট ভাবলাম যে মানে ডেটাগুলো তো র্যান্ডম ভাবে আসতে পারে, তো তাই জন্য ভাবলাম স্ট্রাকচার থাকবে না। মানে
Random
অনেক
মানে
এরর, মানে র্যান্ডম মানে মনে হচ্ছে অনেকে ঠিক রিপোর্ট করতে পারে, ভুল রিপোর্ট করতে পারে, মানে ওই জায়গাটার জন্য ভাবলাম যে আনস্ট্রাকচার্ড হবে এরকম।
okay, see, data, there can be faults in data. Okay, so the faulty data does not mean that it is structured or unstructured. Okay. We need to see whether the data structure is going to be consistent or inconsistent.
আচ্ছা, তাহলে এখানে স্ট্রাকচারটা কিভাবে থাকবে? মানে স্প্যাম রিপোর্টিং হয়েছে না হয়নি এরকম ভাবে?
Yes, yes, that is what we will have. We will have a, let's say for emails. Let's say every email has an email ID. Okay, EID. Every email that is sent is given an ID, and every user have their email account. The email account itself works as the ID for an user. So let's say email ID 101 and some account XYZ reports that this email is spam. So it reports 1, and okay, so another user ABC reports that 101 is not spam. So this is a table data, right? This is a tabular data, which means it can be called as a structured data. Okay, structured data. Is it understandable?
Yes, yes.
Did everyone understand? I'm not talking about one or two people. Okay, I want more voices. Let me hear more voices. Yes or no?
Yes, yes.
Yes, understand.
Okay, okay, great. So we talked about the structured data, that is reporting whether a email or call is spam or not. Okay, so now there can be another type of data, that is unstructured data, which means that the spam email body, the content of the email is also a part of data. Whatever the spam email content is also a part of data, which can have text, images, files attachment, which is a type of unstructured data. Okay, so what we come to know about is that real world data is a mixture of all kind of data. There can be structured data, there can be unstructured data in a single problem. Okay, so yes, so spam filtering has an example of emails, Truecallers, right? Now image classification. A very common example of image classification is self-driving cars. So what do self-driving cars do? They take the picture of the traffic in front of them, and now they identify what vehicles are in front of them, what is the traffic light signal, whether there is someone crossing the road, and according to those data, the self-driving car gives instruction for whether to drive the car or to stop the car. Okay, which uses image classification. So what classification are we doing? We are taking an image and we are classifying whether this is a car, this is a cycle, this is a human crossing the road. Okay, this is the classification we do. Now, temperature forecasting. So, temperature forecasting takes historical weather data to predict the future temperatures, and different kind of weather data can be used, rainfall and etc. etc. Okay, so tell me, is what is the trend? What is the trend of Kolkata's temperature data? Do you remember what trend is?
It's uptrend.
Uptrend. Anybody who wants to say it is a downtrend? Maybe it's snowing in Kolkata. I don't know.
Okay.
Huh? What?
Uptrend.
Uptrend, right? The temperature is keeps on increasing, right? Global warming. Okay. So now this is very common. Friend suggestions. We all have social media platform and we keep getting new friend suggestions. So what algorithms generally do is, let's say we have A, B and C friends. A and B are friends, B and C are friends. So A and C are given suggestions for friend request. So how is this possible? There is a tree-like structure, tree or a graph-like structure which defines connections for each other, right? And therefore gives suggestions for friendship. Okay. Now grouping pictures in phone. So give me an application example which groups pictures.
Google Photos.
Google Photos. So what kind of grouping did Google Photos do for you?
Based on people's faces and location.
Right, based on people's faces and location. What is your name?
Protusha.
Pratyusha. Great, good answer. So we have seen that locations like we see slideshows for in Google Photos, which takes in photos including oceans, photos including hills, and it also classifies in people's faces. These are a part of image classification, where the images are taken into account, but we are not exactly classifying. We are grouping similar kind of pictures. Okay, we are not classifying that this is ocean and this is some person. We are grouping the same kind of person is grouped into one cluster, and the same kind of location is grouped into one cluster. Okay, so this is the difference between grouping and classification. Is this clear? The difference between grouping and classification?
हाँ दीदी
Okay, okay, fine. So robot navigation. So robot
दीदी एक बार
navigation.
रिपीट कर दीजिए.
कौन सा part?
ग्रुपिंग.
Okay, so grouping means that let's say we have A, B, and C images. There is a ocean in A. Let's say ocean. There is a lake in B, and there is a river in C. So the grouping is it groups A, B, C based on what? That every picture has a water body. That is a common thing in all the pictures A, B, and C, that there is a water body. So this means this is grouping the pictures based on its similarity. Okay. Whereas classification, what it does in A image, it will see, okay, there is an ocean, I'll give the output as ocean. There is a lake, okay, I'll give the output as lake. So it is not grouping anything. Okay, is it clear?
Yes, Didi.
Okay. So robot navigation. So we have a very cute, fluffy robot over here. Can anybody tell me which movie, animated movie, was this robot in?
আরে বেম্যাক্স তো এটা।
Okay, Baymax, right. The name is right. What is the movie name?
বিগ হিরো 6।
Big Hero 6, right? Right. It's a good movie. Those who have not watched, please watch it. It's a really nice movie. Okay, so the robot navigation, as we see, they can understand whether there is an obstacle and which desired location they want to reach. Then there is movie recommendation. So let me ask you a question. Is movie recommendation and friend suggestion same kind of algorithm can be used for these two things?
স্লাইটলি ডিফারেন্ট। ফ্রেন্ড সাজেশনের সাথে সাধারণত আমার ফ্রেন্ডের ফ্রেন্ড মেবি আমার ফ্রেন্ড হতে পারে, এইভাবে সাজেশন দেয়। আর মুভি সাজেশনে আমার প্রিভিয়াস যে মুভি দেখেছি যে সেই ওয়াইজ রেকমেন্ডেশন দেয়।
Okay. Okay, so
মুভিতে কি হয়,
হ্যাঁ।
জনরে উপর ক্লাসিফাই
বলো।
করতে পারা যায়, মানে জনরে কিরম দেখলাম, যদি সাইফাই দেখি তো ওরম ভাবে হয়।
হ্যাঁ, okay, okay.
মুভিতে
Else,
আমার
আমি
ইন্টারেস্টের উপরে
কাস্টের ওয়াইজও হতে পারে,
রেকমেন্ডেশন দেখা।
কে কে কাস্টে রয়েছে।
Okay, 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 okay. All those answers are acceptable. So to tell in one word, the difference between these two is the data, right? The data is different. This is movie and this is friend. Otherwise, they are the same. The algorithm used can be used the same algorithms, but a different algorithm can also be used. Okay, so same algorithm is fine, but if the developer wants to put in a different algorithm, they can. Okay, so now after going through the real world examples extensively, we finally get into the algorithms part. Okay, the first algorithm, that is the supervised algorithm. What does supervised algorithm mean? It means that we are providing labeled data into the algorithm, into the machine learning model. So what does labeled data means again? That we have the input and we have the tags for the data or the labels for the data, and we are putting both these things into the machine learning model to find the input output pairs. What does input output mean? The test data, the data that we are predicting on. This data we are predicting the machine learning model, and this data gives the output caret. So this is the input and output pair. Okay. So supervised algorithm has two types: regression based algorithm and classification based. So the main difference between regression and classification is the type of data we use. The data in regression is continuous data, and the data in classification is categorical data. Can anybody give me an example for continuous data? Does anybody recognize this symbol?
Set of
What?
real numbers.
Yes, set of real numbers. What does set of real numbers is from? Minus infinity to
Plus infinity.
প্লাস ইনফিনিটি তো।
right. So why is this continuous data? Because there is no breaks in between the data. Okay, it is one single line. Okay, so these kind of data, are used for regression based, where what we do is, here in the image we see there are so many data points, and we are fitting a line through this data. This line we are fitting, so that all the data points do not fall in the line, but still this line is representing these data points. How? We will discuss in the later slides. Okay, so classification, what classification supervised learning does is, it classifies on categorical data. What is categorical data? It has different categories, like let's say A, B, C, different categories. Okay, they are not continuous data. So now tell me, this example over here, what type of supervised algorithm is it? Is it regression based?
It's classification based.
Okay. Somebody in the background, I cannot hear you. I heard one person saying classification. Who was the other person?
না না আমি জিজ্ঞেস করছিলাম কোনটার কথা বলছিলে, কোন ইমেজটা, উপরেটা না নিচেরটা?
This image, the upper image, this big image we have here. What type of data are we using?
ক্লাসিফিকেশন।
It is classification. Right?
Classification.
Yes, this is classification because it has categorical data. Tomato, carrot, these are not continuous values, okay? Numeric values. So, okay. So next we go into the type of supervised learning. So first we see regression. So what does regression? There are different types of regression. Okay, we will learn about linear regression. So what does linear regression mean? That we have dependent variable and one or more independent variable. So what does dependent and independent variable mean? So we have x and y over here. Okay, somebody is telling. Okay, tell me.
না দিদি, ভুল করে অন হয়ে গেছিল মাইক।
Okay, fine. Okay, you can try. What is dependent and what is independent?
আর ডিপেন্ডেন্ট ভেরিয়েবল তো লাইক ওয়াইটাকে বলে, যেটা বাকি ভেরিয়েবল গুলোর উপর ডিপেন্ড করে, আর ইন্ডিপেন্ডেন্ট ভেরিয়েবল হচ্ছে এক্সটা, যেটা অলরেডি এক্সিস্ট করে আমাদের দেওয়া থাকে।
Okay, fair enough. So x is the independent variable which we already have given, right? And y is the dependent variable which we are trying to find out. So this is the output, right? So, for example, let's say we have a company sale and it is increasing as we see. These data points are increasing. So this is the upward trend. And using linear regression, we fit a line through this data. So there can be many lines, right? This is not the only line we can have. We can have a line through this or something like this. Okay, these are not straight lines, but just assume they are straight lines. There can be infinite amount of lines we are having here. So these lines are represented by the line equation y equal to mx plus b for one independent variable. Okay, so for one independent variable we have this equation. So tell me, what does m signify in line equation?
tan theta slope.
Tan theta slope, right? This is the tan theta, right? And what does b signify?
বি হচ্ছে কনস্ট্যান্ট একটা, মানে ওটা কনস্ট্যান্ট ভ্যালু, যেটা মানে ডিপেন্ড করে, ওটা চেঞ্জ হতে পারে।
B signifying the y
Okay, tell me,
intercept.
for this line, is this value 30 is the b value?
Yes.
Okay, yes. So b value is the intercept. What does intercept means? There is the line crossing the y-axis. Okay, this is the intercept. So b is the intercept. Anybody is asking something? Okay. So, like I was saying, there can be infinite amount of lines going through this data. How do we know which line is the best line? So here comes the fact that error. So the line which gives the least error is the best line. Okay. So the error can be given through two formulas, that is mean absolute error and root mean square error. Okay. So the formula says that it is the summation of absolute difference between the actual value and the predicted value divided by the number of observations. And for root mean square error, it is a square of actual value subtracted by the predicted value divided by n and then the root over. Okay, these are the two formulas for error correction. So, any doubt regarding linear regression? Okay, fine. Okay, now let's try our hand at coding. Okay, let's try. So before we go into coding, we need to know some basic things. Is this visible? Tell me, the collab is visible?
দিদি তুমি এই
Yes.
পিপিটি গুলো গ্রুপে সেন্ড করে দিবে নোটস বানাতে সাহায্য।
Okay. We'll let the session first finish. Okay, we are only for 25% through the session. Okay, so what is machine learning models? So machine learning models is the model that is going to create the algorithm for us for recognizing the patterns, okay, in the data. So there are some parameters or elements of the model, that is the architecture. The architecture of a machine learning model defines the kind of algorithms. That is, the linear regression is a type of architecture for a machine learning model. Right? Now we have parameters. So these parameters are like variables that are passed to the architecture. Like we pass parameters to functions. Just the same way, we pass parameters to these machine learning models to adjust how the training is going to perform. So we have two type of data: training data and testing data. So training data is the labeled data that is going to be used for training the model. That is the model is going to learn the intricate details of the data using the training data. Now there is a testing data, that is the data which the model has not been introduced to. The model does not know what is the content in the testing data, and which is used to predict the model. Okay, so if the predictions are correct, we say the model is good. If the predictions are not correct, we say the model is not good. Okay, so now we have the output, that is, or in other words, the result or prediction made by the model, and the evaluation metrics. So as we see in the PPT, that these calculation are metrics which define how much good the performance of the model is. Okay. Now, before we go into machine learning models, the data must be clean. As I said, the data can be incorrect, corrupted, or incomplete, and therefore, to ensure that the data and the model is accurate and consistent, we need to clean this data by removing such corrupted data. Okay. Now, what is meant by training a model? Training a model means that uh, teaching the machine learning algorithm to give the accurate output. So how is it done? So we iterate. Okay, so we keep looping over the data, and the model keeps seeing these data again and again to make sure that it does not leave out any details about the data. Testing of data, like I already explained, the testing is to understand the model's performance and effectiveness. Okay. So some libraries that we are going to use, machine learning libraries, that is scikit or sklearn library, which is used for creating the machine learning models. Pandas, which is going to store the structured data, that is data frames, also known as data frames. Matplotlib is used to generate graphs and plots. Seaborn data is used to import some sample data and do some plotting of graphs. Okay. So any doubt, any questions in this part?
দিদি বলছি লাইব্রেরি গুলো কি ইনস্টল করতে হবে আমাদেরকে ফর নাও?
No, for now, if you're trying to, okay, I'll send you the Colab. Okay, you don't need to code with me. If you want, you can, but you don't need to. And if you're using Colab, you don't need to install any of these libraries. Okay.
আচ্ছা আচ্ছা।
Okay. So, okay, let's start with linear regression. So here I have imported all the libraries. So this line here, as SNS, these are alias name. Okay, the short name for Seaborn, right? Seaborn pandas, PD for pandas, and from sklearn or scikit-learn. Okay, these are the two same names. These are same libraries. From sklearn, I am importing the linear regression model. So sklearns provide us with the facility of importing these models. We don't need to code the model ourselves. Okay,
এই সি
and
বন্ডটার কাজটা কি?
Seaborn we are using mainly to import sample data. Seaborn has a huge set of sample data, so we don't need to create our own data here. Okay, we are
আচ্ছা
taking data from Seaborn. Okay, and
ও,
yes, so these are the main three libraries that we are using. Matplotlib.
সাইকিট-লার্নের কাজটা একটু রিপিট করুন।
Okay, so scikit-learn gives us the model. The machine learning model is already coded inside scikit-learn library, and it gives us functions to call these models. So linear regression is one such function that we already have, a predefined model. Okay, is it clear?
Yes, দিদি।
Okay, so in the first, okay, so let's connect it. Okay, so in the first, here we see first coding block that I am going to take in the iris data, iris flower data from the C1 module. So what does the iris flower data contain? It contains some length and width of the petals and sepals and stuff. Okay, so it is the data about flowers, iris flowers. Let's see what the data is like. Okay, so we have the data. So we see this sepal length, sepal width, petal length, petal width, and the species for iris data. Okay, there are different species for iris data. Now, for linear regression, what we are going to achieve here, the goal of linear regression here is that I will take the petal length and find the sepal length. Okay, so petal length is my input and sepal length will be my output. So now tell me which of these two data, the petal length and sepal length, is my independent data and which is the dependent data.
Petal length independent, sepal length dependent.
Very good, very good. So the petal length is the independent data and sepal length is dependent data because petal length represents the x. Okay, so here we are taking the petal length from this iris dataset. We are storing the dataset in the iris variable, and we are taking the iris from iris. We are extracting the petal length into x, which is our independent variable, and the sepal length into our y, which is the dependent variable. Okay, so if we let's see what the graph looks like. So let's see the graph. Let's give a different color. Okay. Okay, so this is the kind of data we get. So petal length is given here and the sepal length is given over on the y-axis. So this is the kind of data. So what kind of trend do we see in general?
Continuous data.
Data is continuous, but what is the trend of the data? What does these points tell us? How is the data going?
Okay.
Sorry?
Upward.
Upward, right? So what if is anybody facing a problem with understanding the trend of data? Okay, you can write in chat if you want to. Okay, anyway, I'll explain what is the trend again. The trend means that if the upward trend means that if the x-axis is increasing, the y-axis is also increasing. So we see here this data has a smaller x-axis value and a smaller y-axis value, and this, as we go on the right side of the x-axis data, the x-axis value increases as well as the y-axis value increases. Okay, so this is the upward trend, and the vice versa, that is x-axis value increases but the y-axis value decreases, is the downward trend. Okay, is that clear? Okay, so now we are going to divide the training and testing data. So division division is like 20% of the data, original data, we are keeping it as testing data, and the 80% of the data we are taking as training data. So the 20% of the data we have, we are not going to introduce it to the machine learning. The machine learning will not know what this data has. Okay, what the 20% of the testing data has. Now we'll define the linear regression model. So the linear regression model is defined. Okay, so and we have also trained the data. The training of the data is done. We are passing the X training and Y training. What does it mean? The X means what? The independent variable, and Y means what? The dependent variable. And now we divided the data into 80 and 20%, right? So the training data for X and the training data for Y is passed into the model to train it, and the training is over. Okay, because we don't have much data, we see only few data. Okay, so it's fast enough. And now we are using the X test, which means that the independent variable for the X independent variable from the testing data is used to predict what the output. After predicting the output, we are going to see if the Y test, that is the dependent variable in the testing data, whether this matches with the prediction data of the independent variable in the testing data. Is this too confusing? Did I confuse all of you?
দিদি আরেকবার বললে ভালো হয়, একটু গুলিয়ে গেছে।
Okay. Good. Let me explain it to you. Okay. Okay. Let's say I have a original data. Okay. This is the original data I have. It has two sections. That is X and Y. X is the input and Y are the labels. Okay. This is the labels or the dependent data. X is the input or the independent data. Now what I do is I divide these into training and testing. So training, and I do testing, and also divide the Y into training and testing. Okay, this is represented as X train in the coding, and this is represented as Y train. Similarly, we represent the division of X in the testing data with X test and Y in the testing data as Y test. Is this clear? Is this much clear?
Yes.
That is a very
হ্যাঁ দিদি
okay. Fine. Okay, so we are using the X test for predicting the model. Okay, we are using this. Okay, fine. The X test data for predicting the model, and we are going to match whether this predicted value matches with Y test. Okay, we are going to match these two values. Okay, so let's run this part. Okay, so let's see the plot. Okay. So let's wait a little bit. The connection went off. Okay. Okay, fine. So we have to, I guess, run all of this again.
Didi, can you repeat it? The why X is independent data or Y is dependent data?
Okay, so X is independent because we are using the X data is given to us. We have the X data. X data does not depend on something else. That's why we are telling that X data is independent. Okay, and the Y data depends on X data. See, we write Y equal to mx plus b, so which means Y data is dependent on X data. That's why we call Y as dependent variable. Okay, is it clear?
Yes, Didi.
Okay. Okay. So let's see what prediction we get. Okay. Okay. So linear regression gives us a straight line for fitting the data. So these are the test data. Okay, you see this data is different from this data because we have divided this data into training and testing. So this is the testing part of the data, and for these data we have this line. So how do we get to know with this line? Okay, so let's say the petal length is 5. So we project this line. Okay, so we get a projection from this line to 5 and a projection on the y-axis. So it is the petal length of 5 will give a sepal length of near about 6.5. Okay, this is how we understand. This is what the prediction means. Is this clear? Hello?
Yes.
Did everybody understand? How we are predicting the data from this line? Okay, I take it nobody understood. Do I need to explain again? Okay, if you tell me to explain again, I'll explain.
I want to know this is actually the test data, but where is the train data gone? This data set is looking different from the original data.
Yes, so this data, we have divided this data into training and testing. Okay, so okay, if you want to see the training data, let's try that. Okay, let's try to find the training data. Let's see what it looks like. Let's give it a green color. Okay. So this is the training data. Okay. So if you see carefully, some data from here are missing in the training data. Why? Because these data are divided into the testing data. So if I include the testing data and the training data, I will get the original data. Is it clear?
Yes.
Okay. So I trained the model on these data, and it is giving me this line to find out the values for these testing data. So,
I want to
so
ask a question.
tell me.
Yes, we are taking some data from the actually the original data set, but why we are
Hmm.
not taking the original data only? Why we are splitting it in train data and test data?
The test data, we need to have two types of data. Okay, one training and one testing data. So the testing data is important because we need to know if the machine learning can predict correctly on a new data. If the machine learning is unable to predict for a new data set that it has not seen, we cannot use this model in the real world life, because in the real world life we are always having data, right? Every day we get new data. So we cannot test these, we cannot use these machine learning models if they cannot predict data for a new data. So that is what we are trying to do. We are keeping this test data away from the machine learning model so that we can see whether the machine learning model can predict new data values. Is that clear?
Okay. Yes,
Okay.
yes.
Okay. So this is the kind of prediction we get. So let's see how much uh, good the model is. So we will see the errors, the mean squared error and the absolute error. So we see the error are below 0.5. Okay, below 0.5, which is a good value. Okay, 0.12 for squared error and 0.26 for mean absolute error is a good value. So the model is predicting good, nicely, right? So now let's see the equation of line. In the slide, we discussed the equation of line. Can we find out the equation of line for this line? Let's see. Okay, so here we get the equation. So y is equal to 0.41x plus 4.30. Okay, so the slope of this line is 0.41. Okay, 0.41, and this intercept, this line, if we project this line on the left hand side like this, we'll get this line will cross the y axis at point 4.3. Is it clear? Okay. Okay, fine. Everybody, let's see. Are you still there or not? Spam understood if you understand. You understood whatever we have discussed till now. Okay. Okay, so you are still there. Fine. Thank you for interacting. Okay, so let's go back to the slides. Now we come into classification. So do not get confused by the name logistic regression because it is still a classification. Okay, logistic regression is a kind of classification. Do not get confused by the name. So what is logistic regression? We have in logistic regression we use categorical data. Since it is a classification, we use categorical data. And how many categorical data we have? Only two. Only two categorical data. That is binary classification, which has two given classes. Classes is another name for categories. Okay, categories or classes. Okay, so we find the probability of data belonging to any one of the two given classes. Okay, so let's see a graph here. We have a graph. With this graph, we have data points over here or on the top. So the data points belong to one of the two classes. So the two classes are represented by either 0 or 1. Okay, so if there are two classes A and B, I can represent A and B numerically by 0 or 1, right? So this is what it does. So these points belong to B class, and these points belong to A class. And this is the graph that goes. So at point 0.5 is the threshold value. So what does threshold value mean? It means that if any data point has a probability value greater than 0.5. So let's say I have a data small a. Okay, so the probability for this data is 0.6. So 0.6 is closer to 0.1. Okay, is closer to 1. 0.6 is closer to 1. So it belongs to the B data. And if now if there is a data like if I have another data that is P E equal to 0.2, it is closer to 0. So it belongs to A data, which is represented by 0. This function is also known as sigmoid function. Okay. So the spam filtering that we do can be predicted using this sigmoid function, because we have only two classes, that is spam or not spam. Okay, 1 or 0. Is this clear?
हाँ दीदी বুঝেছি।
Okay. Okay, now let's okay. So let's see logistic regression program. Okay. So we are using the we are not using iris data. Let's just remove this. So we have logistic regression for classification. We are using the same libraries as before. The only difference is we are taking logistic regression from the scikit-learn module. So previously we imported linear regression. Now we are going to use the logistic regression function. Okay, and for the metrics, that is the error calculation. Okay, we did not discuss the error calculation, right? Let's discuss the okay. Fine. Let's do the coding a bit later on. Okay, let's discuss classification completely first. So now the another kind of classification we have is multi-class classification. As the name suggests, multi-class means we have different categories, means multiple categories or classes. Okay, and the input data are divided into multiple categories based on the different features they have. Okay, so we have animation over here. So as we see, these are the three different type of data we have: red, blue, and green. And the algorithm divides this data into different classes. Now, if you see carefully, we have some red data in the blue zone. So these red data are wrongly classified as blue class. Okay, so the red class is wrongly classified as blue class, and some of the green data are wrongly classified as red class. Is this visible to you, guys? Okay. So the error calculation. So how do we calculate these errors? So for errors, we have something called the confusion matrix. So what does confusion matrix mean? So we have the real label on one side and the predicted label on the other side. Okay, so let's say for this data, we have real labels as red, blue, and green. And then on this side, we also have the predicted labels as red, blue, and green. Okay, so so this means that how many of this green value here means that how many of the predicted values they match with the real values. Mean the prediction matches with the real values. Okay, so red with red matches, green with green okay. So put this as green. This is green and this is blue. So green with green matches, okay, and the blue with blue matches. Let's say we have total 10 red data sets that belong to the red category. So let's say 5 of the red matches with the red outputs. 2 of them are classified as green. So 2 of them are classified as green and 3 of them are classified as blue. So these data are wrongly classified. The red data are classified wrongly as green and blue. This is the correct data. Similarly for other classes. Okay, so this matrix, which creates a matrix, let's say like this. Okay, this matrix is called confusion matrix. So from these we can find different metrics like accuracy, precision, recall, which have different formulas. Okay, let's not go into the formula right now. Let's go for the programming part. Now that you know how we calculate the errors, we will go into the programming part. Okay. So as you can see, I'm importing two metrics from sklearn, that is accuracy and confusion factors. Okay, is this clear? What I discussed about multi-class classification, is it clear?
Yes, yes.
Okay, so the confusion matrix can be used for any classification. It can be used for binary classification, logistic regression, or multi-class classification. Today we will be seeing example for logistic regression. Okay, so this is a data set that I have created. Okay, this is a data set which has age, different ages, income for these users, means the person with age 22 has income 30,000, and whether he has bought a house or not. So this person has not bought a house. Another person who is of age 40 and has 60,000 salary has bought a house. Okay, this is the data we have. So we print the data. So the data looks like this. Okay. Now let's see how the data looks graphically. Okay, so this data looks graphically like this. So the red data is the red data are those who have not bought the house, and the green are for those who have bought the house. Okay, so this is the age and the salary. Is this clear? The graph is clear. Hmm.
Yes, yes.
Okay, only Saurav is answering. Ankit, okay. What happened to the other guys? There are 62 of you. Only 2 or 3 people answering is not enough. Okay, 4 of you. Only 4 out of 62. How much percentage does this make? 5. Okay. 5 people only understand out of 62 people. Okay, let me call names. Okay. Okay, fine. Fine. Okay. So now what we do is we are going to separate this data. We are going to separate the independent and dependent variable. So can anybody tell me what are the possible independent variable? In this data, which can be the X data? With age, income, bought, which will be X? Which will be X?
Age.
Which can be
Age.
independent.
Age. What? Sorry? Somebody said something. Is there any messages? Okay, no. So, what is the only age? Anybody else with so many different answers?
We want to predict that that person can buy the home or not, right?
Yes, precisely.
Then probably income and age.
Okay, you are telling that we can use both of these data.
Probably, I'm not sure.
Yeah, okay. So it is correct. It is correct. We can use both these data. We can use any one of these data. But today we will be using both of these data. Okay. I am a greedy person and I will be using both this data. Okay. I won't leave anything behind. Okay. So we have defined the x and y as x as age and income, y as the bought data. Okay. Now I'm again dividing these data into training and testing, but this time I'm not using 20%, but I'm using 25% testing data and 75% training data. Okay. And now I will be training the model. I define the logistic regression model and I will be training the model with the training data. Okay, so the data has been trained, and let's predict the data and see what the accuracy is. So the accuracy is 100%. That is 1. Accuracy 1 is 100%. So as I said, the 100% is a very rare accuracy. It is only possible because these data are very less amount of data. There is not much variability in this data. It is not complex. It's very easy data. So that's why we can see a 100% accuracy over here. Okay. So now let's create the confusion matrix. Okay, so we see the confusion matrix. This is the predicted data. Okay, now the confusion matrix we had in the PPT, in the x-axis we had the real labels, that is the actual data, and on the y-axis we had the predicted labels. But here we have predicted label in the y-axis, x-axis, and the actual data in the y-axis. So it does not matter much. It's same thing. Okay. So what this confusion matrix is trying to say, this dark colors that you see is the actual data of who did not buy. Means the person who did not buy a house was classified as did not buy. Okay, so it is 100% of these data were classified correctly, and also those people who did not, uh, sorry, those people who bought the data were classified as who bought the data. Okay, so this is 100%. As we see here, this is 100% correct data, and on the lighter shades are 100%. 0% wrong data. Okay, so lighter shades are 0% wrong data. So if we want a different shade, maybe we can try. Oops. Okay, so this is a blue data right now. Okay, so blue colors, but the logic is same. The darker part shows that the correctly classified data is more, and the wrongly classified data is less. Okay, is this confusion matrix clear?
Yes.
Okay, now I'll ask one question. Muskan Das, are you there?
Harry.
Okay, so tell me, from this confusion matrix, tell me how many people who actually bought the data were predicted as did not buy the data.
Repeat karo.
How many people who actually bought the data were predicted as did not buy the data, did not buy the house. I'm sorry. Is it clear? Do I need to repeat the question? Muskan, are you there? Okay, unmute yourself. Unmute yourself and let's speak. Are you unable to unmute yourself? Okay, repeat the. Okay, so let me tell. আচ্ছা বাংলায় বলছি, ঠিক আছে? যারা যারা এমন কে আছে যারা অ্যাকচুয়ালি বাড়ি কিনেছে কিন্তু তাদেরকে প্রেডিক্ট করা হচ্ছে কি বাড়ি কেনেনি, এমনি কতজন আছে?
I am not understand Bangla.
What did you not understand? Okay, you don't understand Bangla. Okay.
I don't understand Bangla.
Okay. So ऐसे कितने सारे लोग थे जिन्होंने घर खरीदा पर लेकिन प्रेडिक्ट किया जा रहा है कि घर नहीं खरीदा?
একবার ট্রাই করব।
हाँ, Shaman, sure.
No one.
How do you know that?
বিকজ যদি গ্রাফটা দেখি অ্যাকচুয়ালি ব্রট করেছে সেখানেও গ্রাফের কোনো পার্ট প্লট নেই অ্যান্ড প্রেডিক্টেড ডিডেন্ট বাই সেটাতেও কোনো পার্ট প্লটেড নেই সো
Okay, you mean this part, right?
নো দ্য লোয়ার পার্ট
Okay, this part. Okay, correct. The answer is correct. So the people who bought the house, but were predicted as did not buy the house is zero. Okay, so this white color represents zero. Okay, so let's try by giving our own test data. Okay. Let's give our own test data. Okay, give me a pair of data, age and salary, in the chat box. Write age and salary that you want me to predict whether they buy a house or not. $44 and $70,000. Okay, give me one more. Give me one more. Make it weird. Give 90 age. Okay, okay. I'll just copy this.
Ma'am, in
Oh,
this
this
question I
is
can't
better. This is
understand.
better. Okay, what did you not understand?
Ma'am,
I'm not a ma'am, okay? Please call me Didi.
also, what logic used in this question?
Which question?
ये मैट्रिक्स वाला डोंट बा कहाँ confusion matter.
So we are getting confused with confusion matrix, right?
Yes, yeah.
Okay, so okay, please hold on a second. I'll explain it in 1 minute.
Okay.
Yes.
Yeah, ma'am.
Okay.
I am.
Okay, so the confusion matrix says that the people, the people who did not buy a house were predicted as did not buy the house in this block. Okay, in this block it says that the people who did not buy the house were predicted as bought the house. Okay, so here according to this color scale here, so the dark blue represents that 100% and the white color represents 0%. So which means that people who did not buy the house were predicted as did not buy the house. That is, the correct prediction is 100%. We have a 100% correct prediction. And people who did not buy the house but were predicted as bought the house. That is a wrong prediction. The wrong prediction is 0%. Similarly for bought the house. Is it clear?
Ma'am, so which one is the graph for the predicted one and which one is for the actual?
The below thing, that is the x-axis is for predicted and the y-axis is for actual. Okay, this is actual. We can exchange this. Okay, we can put the predicted in y-axis, actual in x-axis, it does not matter. Okay, so in this graph we have predicted as x-axis and actual as y-axis. Okay.
Excuse me, Didi, I have a question. How to know how many of the given person is actually bought the house but predicted didn't buy?
Bought the house but predicted didn't buy. Okay, tell me, where do you see in the graph those people who actually bought the house? Where is it located? Those people who actually bought the house.
Left bottom corner.
Bottom. Okay, this bottom part is those who actually bought the house.
Yes, left bottom.
Okay, so this part is where we see that the predicted part says that did not buy the house. So which means that actually the person bought the house, but the machine learning algorithm says that this person did not buy the house. Is this box. Okay.
Yes, but how to know that how many of them that the prediction is wrong. For how many
You
people the
want to know
prediction?
the numbers. You want to know the
Yes, number.
numbers. Okay, so let's print this. Okay. Let's print. So here you see this printing as 0, 1, 1, 0. This is the probability. So 1 for probability, 0 probability. So the prediction is done using probability in classification. We don't do the probability as percentage, right? We do it as percentage or probability. We don't do it using numbers. Okay.
Okay.
Okay, so that is why I am asking these values to show you what the values are actually coming as. Okay. So according to these two values that we have, 44 age and 70,000 salary, 89 age and 98,000 salary. Tell me what should be the status of buying a house? Is it yes or is it no?
Yes.
For both? For both the data set, is it yes?
Probably, I think.
Okay, let's try. Okay, we are not printing it yet. Okay, so the array gives that this 44 years old person buys a house, but an 89-year-old person does not buy a house. Okay, this is what the prediction gives us. So okay, so we cannot do anything about it. This is what the prediction is. Okay, the prediction is not satisfactory, but it is what it is. Okay, so there is some even though the accuracy is showing as 100%, there is some mistake here. Okay.
Didi, why 89 not bought the home?
The why is the fact that we cannot answer, because in the starting I said you that machine learning is black box model. We don't know what machine learning is doing inside. Okay, we don't know what algorithms it's using. Okay, so I cannot say why it predicted like this. So what we can do for correct prediction is provide more data. We need to give more data so that it can understand the prediction, understand the pattern or the trend of data more easily and perfectly. Okay.
Okay, Didi.
Okay. So finally we come into the final
Ma'am,
section.
can you add two more data previously there and see that what is the pattern?
You want me to add these data into the original data
No, ma'am. Here only. Please add two more datas.
in the testing? What
Yes,
data?
ma'am.
Tell me.
Two very odd datas, like one from the first one, similar to
Okay.
the first one, and second
Okay.
to
Let's say 13 years of age. Can we buy something in 13 years of age with 10,000? Probably not, right? And let's go for 89. Okay, let's go for 89 age, but give a higher value of this is 1,20,000. Okay, let's try this. So it gives 0 for both again. So this is correct. The 13 years of old age at with 10,000 salary, we cannot buy anything. But for this data, this is not correct. The higher age data is not giving a correct value. Okay. So we see that there is some problem with the machine learning model, and which can only be solved when we have more data set to give for the machine learning model to use. Okay. So with no more further ado, let's start with the unsupervised learning. We are already running late, I think. Yes, we are running late. Okay. So, okay. So what is unsupervised learning? Unsupervised learning uses unlabeled data. So here we see that we are only providing the input. There is no label. Okay, this is unlabeled data. But still, the machine learning algorithm classifies the capsicums, brinjals, and onions together. Okay, so how is it classifying? It is classifying based on color, shape, and color. Okay, different type of. So it's grouping based on similarity between the data points. Is it clear?
Yes, Didi.
Okay. So there are one type of unsupervised learning that we are going to learn is clustering. So what is clustering? Clustering is a type where we group similar instances together. Okay. Based on what? Based on their characteristics or the closeness between them. The closeness. How do we understand whether two data points are close? We understand by the distance between two data points. Okay. It tells us whether they are close or not close. Right. So one such algorithm is k-mean algorithm, hierarchical clustering. Okay, these can be used for what? Customer segmentation, anomaly detection. So what does customer segmentation mean? So let's say we have in Amazon. Okay, there are two, let's say three kind of users. One user who buys some products, but with a long duration. Okay, so let's say a user who buys one product in 1 month. Okay, one product in 1 month. Another data of a user who buys one product in 1 day. Every day that a person buys something from Amazon. And another user who does not buy anything for 6 months. Nothing for 6 months. Okay, so if we group these kind of data, what we do, this is someone who is uh, averagely active. So it is sometimes, this person is sometimes active, sometimes not active. This is someone who is always active. And this person who does not buy anything for 6 months is not active, inactive. Okay, so this is what is called customer segmentation. We are dividing the customer based on some features. So the feature is the occurrence of buying within some time. Okay, is this example clear?
Yes,
Okay,
Didi.
fine. Okay, fine. Okay, fine. Just like this example, we see another example over here. That is the blood count. Okay, so there is a different. This is a microscopical image of blood. Okay, so now the clustering algorithm classifies different kind of bloods, as this dark green represent this yellow, probably platelets, and these red smaller green dots represent the blood cells. Okay, this is how real life the clustering occurs. Okay, so, yes, so the next data. Next. Okay, so we explain what is k-mean algorithm. Okay, so the k-mean algorithm partitions the data based on k clusters. So what does k cluster mean? We have a given value k. So k is something that is given. So k can be 3. So 3 means I want 3 clusters. If I have 10 data, I want this 10 data to be divided into A, B, C. If this is 4, I want the 10 data to be divided into A, B, C, D. Okay. So the k is the number of clusters to form. Then again there is a centroid. What does centroid means? So these different clusters have a central point. Okay, a central point. So these central points are called centroids. And in k-mean algorithm, the central point is calculated as the mean of all the points. Okay, the mean value of all the data points in A is the centroid of A. Okay, so now we have the distance metric. So what is the distance metric? It is the distance between 2 points that decides whether they are close or far apart. So if I have this point, let's say A1, this point A2, and this point here A3, so the distance between these 2 points are close. So there is a more probability of these 2 points belonging to a cluster and this point belonging to another cluster. Okay, since this is far away from both these clusters. So what one example of distance is Euclidean distance. Anybody can say the formula for Euclidean distance? You have been using this distance from 12th standard.
দিদি ওই তো root over x minus x bar whole square এরকমই কিছু না?
That's correct. That's correct. Okay, this is the data we have. Okay. So this is x1. Okay. This is the distance. This is the common distance measure that we use. So need to erase all this. So next you can see the animation where there is some clusters we see. Okay, these are the centroids. These are the centroids, and these are the clusters. Yellow, green, blue. Okay. So again, so we are initializing these centroids randomly at first, and then we are assigning these data points one by one to which centroid they belong to based on the distance from the centroid, and we are updating the centroid. Okay, so with every iteration the centroids are getting updated and getting placed in a proper position, and this iteration stops when the centroids do not change anymore. The centroids value have become constant. Okay, then this k-mean algorithm stops. Okay. So there are some advantages of k-mean algorithm, that is simple and scalable. The disadvantages are sensitive to initialization, which means that the centroids are first initialized randomly. So the random value affects the k-mean algorithm. Okay. And then we have the spherical clusters. As we see, I can draw a sphere around these clusters. I can draw a sphere around these clusters, right? So the k-mean algorithm assumes that all the clusters are circular, okay, which is a disadvantage, and it requires a predefined k. So we have to provide the given k value. This is a disadvantage. The algorithm cannot automatically understand how many groups to make, but we have to tell the algorithm the number of groups. Okay, is this understandable? Is this clear? Please respond.
दीदी एक बार रिपीट कर दें.
कौन सा पार्ट रिपीट करना है? कुछ भी समझ नहीं आया यहाँ पे?
दीदी.
Okay. So we have a randomly initialized centroid values. That is, this value we are randomly initializing. Let's say x, y, z. We are randomly initializing in 5, 10, 15, something. Okay. These three values are randomly initialized. Now we are measuring the distance between these randomly initialized centroids with the existing data points, and we are updating the value of centroid based on the closeness of the data points. Okay, so this red value, that centroid is close to this red value. So the value of centroid is getting updated again and again through iteration, and by this iteration the centroid value goes in place in the correct places, that is in middle of the whole clustering, the data cluster. Okay, and this algorithm stops when this updation of the centroid value stops. When the centroid value becomes constant and is not changing anymore, then this k-mean algorithm stops. Is it clear?
Understood, दीदी.
Okay, so the disadvantages of k-mean algorithm can be overcome by another clustering algorithm called hierarchical clustering. But since we are out of time today, we won't be going through hierarchical clustering. Okay, so we'll directly go into the coding part for unsupervised learning, that is the clustering. Okay, so from this we are importing from the k-mean function from scikit-learn module, and the rest are the same. Rest all of it is same. Okay. So now we are again using the flower data, the iris flower data that we use for linear regression. Okay. Now as I said, I am greedy. So this time I will be using all this data to predict the species of the flower. Okay. So let's see how many species do we actually have. Yes. Okay. Species. Okay, so we have 3 species of iris flower, and I want to predict these species using this 4 data: sepal length, sepal width, petal length, and petal width. Note that the k-mean algorithm, we are only so here we are initializing the k-mean algorithm. So we are initializing with 3 clusters. Why 3? Because we have 3 species. Okay, and we are fitting the data. So note that we are only passing X data. We are not passing these species. So this is an unlabeled data. The k-mean algorithm does not know which species these flowers belong to. Okay. Okay, so we have done the training, and let's see. So here we see that the species have been given cluster values. So the cluster values are numeric, 1, 2, 0. Okay, so to understand this data, which cluster means which species, we need to plot the data. Okay, let's plot it. Okay, so we get the plotting. So what does this plot show? So we have 3 species. The Setosa species is given by the circular points, and the versicolor is given by cross points, whereas the virginica is given by the square points. Okay. Now this is the cluster. These species already exist. Okay, these are the actual data. And now the cluster, the color of the point is the predicted data. So 0 refers to, as we see, blue color, which identifies most of the versicolor species. Right, the cross species is identified by blue color, that is 0. And the the cluster 1, that is the orange color, specifies the Setosa species, whereas the green color, that is 2, specifies the virginica. We see there is some error, that these square boxes which represent virginica are classified as 0 cluster, that is the blue color, which represents this cross data sets. Okay, so there is some error over here, we can see. Is this clear? The graph is clear?
Yes, Didi.
Okay, so there is some error. So these we won't. Okay, so that is it. Okay. So the error is always error is unavoidable. Machine learning, as I said, cannot predict 100% of the data, but with more variety and more number of data, we have only 150 rows, which is very less. If we have more like 1000 data or something, there could have been a better classification or better clustering. Sorry, okay, better clustering. So we won't be going into hierarchical clustering today. Okay, but I'll tell the advantages of hierarchical clustering. That is, we do not need to predefine any kind of k value. Okay, so the hierarchical clustering on its own can define the number of clusters that can exist. Okay, there we have a graph-like structure for hierarchical clustering, which is called dendrograms, which is an advantage, and it is flexible. Flexible meaning that I can have any number of clusters. I can have 2, 3, 4, 5, one cluster also. And the limitation is that it is more computationally complex. Means it takes more time to train this kind of model. Okay. Okay. So how do we understand that whether the clustering is good or bad? So the clustering is understood whether it is good or bad by what? By the measure of closeness. So what does mean the measure of closeness? We mean that two data points belonging to the same cluster, how close are they? Okay, some data points that belong to the same cluster should be close to each other, right? So what is the measure of closeness between the data points of the same cluster? Okay. Similarly, we can also measure the distance between two different classes. So two different classes data points should be far away from each other. A and B data points in A should be far away from B, right? So we can measure this distance as well to understand how much variance the two different classes are. So ideally, it should be uh, the, the variation should be large, which means the distance should be large between A and B dataset, B class. So here we see that some of the classes here are merging over. Okay, they are very close by, which is a bit confusing, for the machine learning algorithm. Okay, because there is a possibility that this green data was actually red, and it has been predicted as green. Okay, is it clear this part? Okay, everybody is silent. Okay, it's fine if you.
Yes.
Okay, okay, fine. Okay, fine. So we are coming to at the end of the data set. Okay, so now remember the problems that we discussed, the real life problems that we discussed at the beginning of the lecture. So can we now classify these as different kind of with different kind of algorithms? Can we? So tell me, what does spam filtering? Which kind of algorithm can we use for spam filtering? Quickly, quickly. We are running out of time. Quickly. Okay, so I see everybody's comfortable with
Emails and
chat.
call.
Spam
What?
filtering means the unknown callers.
Unknown calls or spam emails.
No, which algorithm should I use for spam filtering? Which machine learning algorithm should I use for identifying whether an email is spam or not spam?
Logistic regression.
What regression?
Logistic.
Logistic. Why?
Well, spam, it's either spam or not spam, and logistic regression is binary in nature, so.
Very good, very good. What is your name?
It's Anabil.
Anabil. So you were listening the whole time. I'm glad. Okay. So the spam filtering comes under logistic regression. Okay, logistic regression because it is a binary data. It is either spam or not spam. Tell me, image classification. Image classification. What kind of algorithm should I use? It is already written. Okay, it is already mentioned. Image classification. Okay, so I take it nobody was listening. Is it? Nobody was
I can't
listening?
recognize it.
What? What?
Image clustering.
Image clustering. Okay. Okay. Clustering and classification are different things. Are you checking the internet and answering? Because
Multi-class
that is
classification.
multi-class classification. Okay. Multi-class classification is an acceptable answer. Okay. It can also be binary class. Okay. This because if we have two animals like cat and dog, it is just two classes, so it can be any kind of classification. So general, let's put it classification. Okay. Temperature forecasting.
Regression.
What regression?
Linear regression.
Okay. Linear regression is a correct answer, but for in real world data, it may use more complex regression, which are polynomial maybe. Friend suggestion. Friend suggestion. Okay, so friend suggestion can use classification as well as clustering. Okay, both are applicable. Right. Similarly, same for movie recommendation, classification and clustering both are applicable for these two. Grouping pictures in phone. What is this?
Cluster.
Clustering.
Clustering. Good. Robot navigation. I did mention it. We did not study about robot navigation, but I did mention what the algorithm robot navigation uses. Anybody remembers something starting with R? Reinforcement. Okay. Reinforcement learning. Okay. Fine. So let's see if our answers were correct. Okay. So temperature forecasting, regression. Okay. Spam filtering, image classification comes under classification. Clustering, grouping pictures comes under clustering. Okay. Robot navigation comes under reinforcement learning. Okay. So PCA is another kind of unsupervised learning. We have not learned about it today. Okay, so we have come to the final slide of our session, which says that even though data science and machine learning have potential for a lot of innovation, you must not hack your friend's mobile. Is that clear? Give me answers. Is that clear? You are supposed, okay? Okay, so what is this sad face for? Okay, okay. So you are not supposed to hack your friend's mobile social media account. You are supposed to be ethical, responsible, fair, and transparent. What does fair mean? Fair means that if I have a data which I collect a real data. Okay, this is a real data which says that people who are black in color and people who are fair in color have a dark complexion. People who have, okay, let's write dark. Black is not the correct word to use. People with dark complexion make more crimes, and people with fair complexion make less crime. No crime. Okay. This is a unfair data. This is a unfair data, not fair. But okay, not fair. But this is a real data. So what do we do? In this case, we need to tell the machine learning algorithm that do not use this kind of data. Do not use this kind of data. So all of you go to ChatGPT and type type something. Do dark skin people make more crimes than fair skin people? See the answer what ChatGPT gives. Okay, is it biased? Is it unfair? Okay, try it. Okay. What does transparency mean? Transparency means that whatever the algorithm uses, as I said, the algorithm is a black box, but we need to try to understand what the algorithm is doing. Okay, there are methods like Xi, which makes us help understand something of this black box, some features of this black box. It helps us to understand. Okay, these features must be implemented to have so that we can have more faith in machine learning algorithm. Is it clear? Okay. So thank you everyone for being so patient and sticking through till the last of the session. Okay. So tell me guys, tell me in the chat box, did you enjoy? Give out of 10, how much did you enjoy the session? Out of 10. 10 on 10. My goodness. This 9.999. You're a very strict teacher, Anabil. Very strict. 9.999. I'm sad. Okay, fine. If you enjoy the session, that is what is required. Thank you for joining, everyone. Okay, so the session's over.